Okay, now that you know that atoms have charges, we're going to know more about this time, about the difference of atomic particles so, so now that you know that atoms have charges, this time we're going to know more about the different atomic models proposed by many known scientists during the early time. This time we're going to dive into our lesson proper. So for our lesson objectives, so everybody please read.
At the end of the lesson, the students can identify and describe the structure of atoms, explain the different models of the atom, and determine the number of protons, neutrons, and electrons of particular atoms, and differentiate analyte from anion.
So this time, let us discuss the different atomic models. The first atomic model was proposed by John Dalton. It was started by John Dalton in 1873, wherein he hypothesized that atom is like a solid sphere, just like this. And wherein he also concluded that this atom could not be divided into smaller particles. So this was the first atomic model, and this was proposed by John Dalton in 1873. And according to John Dalton also, that atoms are invisible, meaning to say we cannot see anything because atoms are too small to be seen by our naked eye. Then, in 1904, it was followed by the Joseph John Hobson atomic model, which is what we call the Planck-Paddy model. The Planck-Paddy model. So this is our atom, and according to Joseph John Hobson, this atom of a particular atom of an element is purely positive. So it is surrounded by the negatively charged particles. So these are tiny particles in these tiny circles with the negative sign inside. So this is our negatively charged particles, which are the atom. Outside of this, these positive sign are the protons. Okay. This time, let's proceed to the next atomic model. This was the third model. In 1911, it was proposed by Ernest Rutherford. Nuclear atomic model, wherein he described the atom as having a tiny dense and positively charged core called the nucleus. And according to Ernest Rutherford also, that the atom of a particular element is always concentrated to its nucleus. Then this is our, as you can see here in this model, you can see there that there are negatively charged particles, which are the electrons, circulating around these positively charged particles, the proton, just like the planets surrounding or revolving around the sun. Then Niels Bohr proposed his atomic model in 1913. He called this model a planetary model because the electrons, as you can see in his model, the electrons is traveling in defined circular orbits around the positively charged nucleus. And according to Niels Bohr also, he concluded that the electron will have a more energy if it is located away from the nucleus, whereas the electron will have a less energy if it is located near the nucleus. This time, let's take a look at the subatomic particles properties. So as you can see here in this table, you can see there that the electrons, for our electrons, we have the symbol for electron is the small letter E with a negative sign beside it. And it is always, of course, it is always situated in the electron cloud of an atom. And of course, it is always a negatively charged. And it has the atomic mass unit of 1,840 and actual mass in grams of 9.11 times 10 to the power of -8. And the proton, it has a symbol of P, small letter P with a positive sign at its side, and always is located at the center of an atom, which is the nucleus. It always is positively charged subatomic particles. It is a relative mass of 1 and 100.67, actual mass of 100.67 times the power of -24. Same also with the neutron. So the neutron has the atomic symbol of N with to the power of 0, and always it is situated at the nucleus together with our proton, and it has no charge, and it has a relative mass of 1 and actual mass, same with the proton. So far, you know that you know the different subatomic particles of an atom, which are
electron, proton, and neutron.
and how they are arranged in the actual model of an atom. And among these subatomic particles, it is also the number of a proton that identifies the atom of an element. And always remember that the all atoms of an element, it is always contained with the same number of protons in their nuclei. And this is what we call the atomic number. So here we have the atomic number, and for our symbol for the atomic number is the capital letter
Z.
So, and when we say atomic number, that is, we can see this as an individual number of a particular element here in our periodic table. And this, aside from that, this atomic number, it is also the number of protons that you can see here in our symbol. So, like for example, is here in our periodic table, you can notice there that there are no two or more elements having the same atomic number. This is because every single, all of the elements here in our periodic table, they have their own atomic number. And I want you to remember also the mass number, which is in our symbol for the mass number is the capital letter E. And take note always that the atomic number, the mass number, or the atomic weight, they are not different from each other. They are always the same. So all atoms of an element contains the same number of proton in their nucleus. So this number of proton is always equal to the atomic number of an element. So meaning to say, if this particular element here in our periodic table, it has a number of protons, 5 protons in its atom, meaning to say this element, it has also a atomic number of 5. So what is the number of protons? What is the number of element of atom in all elements is the same in its atomic number in its protons. The neutrons may vary, and this is what we call the isotopes. So as you can see here in our example, we can notice there that we have the three hydrogen atoms, which is the protium, the deuterium, and tritium. And if you take a look of the atomic symbol of these three hydrogen atoms, you can notice there that they have the same protons in their atom. And in terms of their neutron, they have different neutrons. So they do not have the same neutrons because these are the isotopes. And when we say isotopes, these are the atoms that have the same number of electrons and protons, but the neutrons, the number of neutrons are different. So everybody please read.
The number of neutrons is equal to the difference between the mass number of the atom and the number of protons. The number of electrons in the neutral atom is equal to the number of protons.
So I want you to always remember that when the atoms of a particular element is neutral, I want you to always remember that the electron and the proton of this element is also equal. So that is if the atoms of this element is a neutral. Now, this time, I want you to take a look of this. Class, always remember that this, again, this is the symbol for atomic number, that is correct. So, when you see atomic number, which is equal to the number of proton of an element, that is also equal to the number of electron of an element. So, for example, here in our periodic table, you can notice there that the hydrogen, it has an atomic number of 8. Very good. This is our atomic number. This number above this symbol of 8. Very good. So meaning to say that if it has an atomic number of 8, it has also the 8 protons and neutrons in its atom. And in terms of atomic number, again, this capital letter A, this is our symbol for atomic mass or mass number. Again, if we are looking for the atomic mass of a particular element, so how can we get this 1? So simply we can get this 1 by adding the number of proton of a particular element to its neutron. We can also get this 1 by adding the number of electrons and the mass number or the atomic atomic weight of an element is neutron. How about if we are looking for a neutron of an element? We can get the neutron of a particular element if we going to subtract the element's atomic number to the elements proton, electron, and atomic number. So very good. So this time, so everybody please read.
Iron is a particle of molecules in the energetical charge. The charge of a proton is considered negative by convection.
Okay, so why there is a loss or a gaining of electron? See, possibly this happens because there is a bonding between an atom, and because they need always to attain the stability. And in order for an atom to be stable, it is necessary for an atom to lose or gain an electron. So we have two types of ion, which is the cation and anion. The cation is,
Positively charged due to the removal of electrons.
so meaning if an element loses an electron in its charge will become a negative. How about for anion? The anion,
Negatively charged due to the addition of electrons.
so meaning if an element is gaining an electron, its charge will become
Negative.
Okay, very good. Now, for further information, so this is for your enrichment, we're going to watch a video.
Atomic structure. In this video, we're going to go over atomic structure in a very simplistic and basic way. Atoms are the basic unit of chemical elements. They contain subatomic particles in the nucleus and in the electron cloud that surrounds the nucleus. These subatomic particles include protons and neutrons, which are located in the nucleus, and electrons, which are located in the cloud or field that surrounds the nucleus. Protons have a positive electrical charge, neutrons are uncharged, and electrons have a negative charge. The number of protons and electrons are equal, so atoms are electrically neutral particles. If we look at a model of the element carbon, which has 6 protons, 6 electrons, and in most cases 6 neutrons, we can see the electrons in simple rings or shells surrounding the nucleus. Each shell represents a different energy level, and it can only hold a certain maximum number of electrons. In chemical reactions between atoms, only the electrons in the outermost shell participate in the resulting chemical bond. In atoms with only one energy level or shell, 2 electrons are required for stability. If we look at helium, which has only one shell or energy level, we see that it is full because it contains 2 electrons. So helium is stable, and there is no naturally occurring compound containing helium. Hydrogen, which also has only one ring or shell, possesses only 1 electron in its shell, so it's chemically reactive. In atoms with more than one energy level or shell, 8 electrons are required in its outermost shell for stability. So neon, which has 8 electrons in its outermost shell, is stable. And oxygen, which has only 6 electrons in its outermost shell, is chemically reactive. Atoms that do have fewer than 8 electrons in their outermost shells will try to share, gain, or lose electrons in order to become stable. This is called the octet rule. But there are some exceptions, such as we saw with hydrogen and helium, which have only one energy level or shell. And that be the basics on an atomic structure.
Okay, this time we will perform an activity entitled Charge It with Experience. So last meeting, I told you to bring this following materials, the meter stick, the balloon, the string, the chairs, the glass, cloth, which you already have. So this time, we'll do this activity as a whole. So this time, you will be given a 10 minutes to do this activity. So for your procedure for your activity, so there it is. So everybody please hurry.
Inflate the 2 balloons, tie each using a length of string, place the metronome stick across 2 chairs, suspend the 2 balloons so that they hang freely about 2 inches apart. With each hand holding 1 balloon, rub the balloons simultaneously against your hair several times. Let go of the balloons. Observe. Grab the piece
Okay, are you ready, class?
Yes, sir.
Okay, this time you're going to proceed to your group now for this activity. Take note that you will be given 10 minutes more to do this and perform this activity. Okay, everyone please proceed now. everyone. And let's give ourselves a 5 love claps again. Okay, now based on this activity, I want to ask you a question again. So what happened with the balloon when you rub it simultaneously against your hair several times? Okay, anyone? Okay, Miss Asleya, do you have an idea?
So yes, sir. So when we rub a balloon repeatedly into our hair, it will cause the balloon to become electrically charged. So when we pull the balloon slowly away, like this, when we rub it and pull it slowly from our head, we can see that the two opposite charge of static charge is attracting it with each other. So the reason for that is because the negative charge of the balloon will attract the positive charge of our into our hair, of positive charge proton of our hair.
Okay, very good. Let's give Mrs. Leia a clue that when you rub this this balloon against your hair, it will repel another balloon, and it will attract the balloon. Very good. Now, my second question is, did the balloons acquire the same charge or a different charges? Yes or no?
Yes, sir.
Why did you say so?
Rubbing the balloons against the hair or the wood causes the balloons to become electrically charged.
Okay, very good. Okay, last question. What happened in the balloons when you rub a piece of plastic sheet with a cloth and break it between the two balloons? Anyone? Wants to share their insight? Okay, Miss Asleya, do you have any idea? Again, the question is, what happened with the balloons when you rub a piece of plastic sheet with the cloth and bring it between the two balloons?
I think the plastic will stick to the balloons.
It's because of?
It gains an electron.
Okay, very good. That's correct again. This time, please get one more sheet of paper for our short assessment. This time we're going to have a short assessment. So are you ready, class?
Yes, sir.
So everyone please read the direction.
Choose the letter of the correct answer. Write your answer on a separate sheet of paper.
So take note that your quiz for today is composed of 2 parts. For the test 1, you're going to answer a multiple choice, and for our test 2, let's see it. Okay. Question number 1 and 2. Eyes on your paper, on your own paper. Can we move to the next slide?
Yes, sir.
Okay, next.
Yes, sir.
Okay, for our test 2, so using this periodic table, you're going to complete this table by filling up the blank. So just write your answers on the back of your paper. The space provided in here. Are you through?
Yes, sir.
Okay, papers up. You are already done answering our quiz. Okay, pass your paper forward for everyone who want to check that. Okay, thank you everyone. So let's call it a day. I hope you have learned something. Thank you for your cooperation. And may God bless us all. So, okay, for our okay, so for your assignment, in your assignment notebook, you're going to answer the following question. So you're going to answer an essay. So first question.
How does the size of the atom compare to everyday objects? In terms of charge and location, what is the difference between the subatomic particles of an atom?
And
Differentiate the ion from anion.
okay, this will be written in your assignment notebook. It will be submitted in our next meeting. Take note also that for the rubrics for your assignment. So the content, if your content is correct, you will be given 3 points. For your organization, 1 point. Grammar, 5 points. For each number, if you get this, all of this, you will be given 10 points. And all in all, this activity is 15 points. Okay, let's call it a day. Thank you for your cooperation. I hope you have learned something for our today's class. And may God bless us all.
Hindi sila video.